Good day, math learners! Welcome to Session 9, Equation of an Ellipse. Before we begin, do not forget to subscribe and click the notification bell so that you get notified whenever I post new video lessons online. Let's begin! For this session, we'll be showing you how to derive the equation of the ellipse. Recall the definition of an ellipse that we have discussed in the first session for this particular conic section, Session 8. An ellipse is the locus of points on a plane whose distances from two fixed points add up to a certain constant. The fixed points are called the foci of the ellipse. So the singular form for foci is focus. Since we have two of these points in our ellipse, that's why we have foci. Now, let us try to derive the equation of an ellipse.
So, let us now try to derive the equation of our ellipse. So, let me move it here. Let me draw first the ellipse, okay, for better illustration. Better visualization. So, this is our y line. And let this be our x line. So let us identify now our foci. Let us say this is point f sub 1 for our first focus. And this is our second point, our second focus. So that's our two foci. Okay? The plural for focus is foci. The singular is, of course, focus. Let me draw the ellipse. Let us say our ellipse is this. So let that be our ellipse, and let this be our point on the ellipse, point P. Point P has coordinates x, negative y. Alright? So if from the focus to the center of our ellipse is C, if the distance from this point to that is C, and so is this, then the coordinates of f sub 1 would be negative C, 0, and f sub 2 would have the coordinates C, 0. And we know that based from the definition, this segment, the distance of this segment plus this segment here, so we have P to f sub 1 plus P to f sub 2 is equal to a common sum. A common sum because that particular sum is also equal to the sum of the segments of all the points in this ellipse that will be joined, that will be the distances from the two foci and the point that we may be able to identify, just like point P. Okay, for instance, we have a point here. Let's say this is point R. Then from f sub 1 to R plus f sub 2 to R would have the same sum as from P to f sub 1 plus P to f sub 2. Okay? Let us try to assign a common sum. Let us say that's 2a. Okay? Why 2a? The 2 here actually will aid us in our computation. This will make our computation a lot simpler. So if that is so, let's try to list down the coordinates here so that it will be easier for us to assign the coordinates when we do the computation for the distance formula. Alright, so point P has coordinates x, negative y, f sub 1 has coordinates negative c, 0, and f sub 2 has coordinates c, 0. And so, we can simplify this to here. We can have P to f sub 1 equal to 2a minus P, distance from point P to f sub 2. Moving forward, from here, using the distance formula, we can have, this is x plus c for x minus negative c, that's x plus c squared, plus negative y minus 0 is negative y, but that's squared, equal to 2a minus the square root of, from P, we have x minus c to f sub 2, quantity squared, plus squared. Okay? And so now we square both sides of our equation to get rid of the radical sign here. So we would have, let's simplify this immediately. So we have x squared plus 2cx plus c squared, and this is just plus y squared. Here, 2a squared is 4a squared minus 4a square root of x minus c quantity squared plus this is just y squared. Where did I get 4a? Well, we can liken this one to a square of a binomial. So when we square a binomial, this is our first term and our second term, the whole of that. So we would have this one squared, so that's 4a squared, minus 2 times the first and the second term. So the first term is 2a, 2 times 2a is 4a, times that one, plus the inside here, this one rather squared. So we can remove the radical sign. So we would have x minus c is x squared minus 2cx plus c squared, and that one is plus y squared. Okay? Now, we can remove terms at the left and the right side of our equation. Terms which are similar and with the same signs. Okay? Because when we join them together to one side of the equation, they would just equate into 0. Okay? So, for example, we have y squared. When we move this to the right, this becomes negative y squared. Plus the y squared here. Oh, sorry, we're not able to see that. Plus the y squared here. So, negative y squared. When this is transposed to the right, this becomes negative. So, plus y squared, that becomes 0. So, we can just remove them. Okay? And so, it's this, x squared and that. And c squared and that one. Of course, we cannot remove the 2 because when this is moved here, this becomes negative 2cx. So, we would have negative 4cx there. So, those are the only terms that we can remove and we can proceed. We can move this to the right, to the left side of the equation so that it will be a lot easier for us also to remove this radical sign later. Okay? So, we would have 4a square root of x minus c quantity squared plus y squared equal to 4a squared. And this one, we transpose this to the right, joined by this, we have negative 4cx. Okay? And then we divide both sides of our equation by 4 because they all have a common factor of 4. So we can have here a square root of x minus c quantity squared plus y squared, and we have a squared minus cx. Moving forward, let me move this up. Alright, so from here, we can now remove the radical sign by squaring both sides of our equation. So we have here a squared, and this becomes x minus c quantity squared plus y squared. Okay, and this one becomes a raised to 4 minus 2a squared cx plus c squared x squared. And we can expand this, so we have a squared here times this one is a x squared minus 2cx plus c squared plus y squared, and we have a raised to 4 minus 2a squared cx plus c squared x squared. Okay, moving on, we would have here a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared. And here we have a raised to 4 minus 2a squared cx plus c squared x squared. Now, because these two here have the same signs and they are on opposite sides of our equation, we can remove them. Okay, so we can transfer here. Let me move this up here. So we have now, what remains is we have a squared x squared plus a squared c squared plus a squared y squared equal to a raised to 4 plus c squared x squared. Now, I can join these two together because they have x's, and this and that because it has a's. Okay, so we have a squared x squared, transpose this here, negative c squared x squared plus a squared y squared equal to a raised to 4, and that term transposed that to the right, minus a squared c squared. We can group these two. The common factor here is x squared times a squared minus c squared, okay? Plus a squared y squared equal to, this one is a squared times a squared minus c squared. I hope you were able to follow. Were you able to follow? So let's proceed. And so, if that is the case, we can actually assign, let's assign a particular, another variable to represent a squared minus c squared here. We can let this be equal to b, okay? If b, we let b be equal to the square root of a squared minus c squared. And so from that, b squared would be equal to a squared minus c squared. Okay, and so if that's the case, then we can say, therefore, that from here, a must be greater than b. And going back there, we would have replacing a squared minus c squared by b squared. So we would have b squared x squared plus a squared y squared equal to a squared b squared. Okay, and going further, if that is the case, then b squared x squared plus a squared y squared equal to a squared b squared. If we divide both sides by a squared b squared, we would have this one divided by a squared b squared is x squared over a squared, plus this divided by that, y squared over b squared, and this divided by that would be equal to 1. Okay? And this is the equation of our ellipse. Okay? Equation of our ellipse. From here, when we let b be equal to that one, we assumed that a, here, let's have it here. We assumed that a is greater than c also, because we cannot have a negative radicand here. So a must be greater than c. And from there, actually also, a is also greater than b. And if we're going to just focus on a being greater than c, this is actually true through the triangle inequality. How? How can it be true that a is greater than c? If we're going to look back to our illustration, P of f sub 1, the segment, plus the segment is equal to 2a. The triangle inequality says that the sum of the two sides is greater than the third side of a triangle. From there, we can say that because this is equal to 2a, therefore 2a is greater than 2c, because the length from this point to that, if this is c here and c, then that should be 2c. And therefore, a is greater than c. That's why this, assuming a is greater than c, is actually true by the triangle inequality. So again, this is now the equation of our ellipse. X squared over a squared plus y squared over b squared equal to 1.
That's it, math learners! I hope hope you have learned something today as we derive the equation of an ellipse. In the next session, we will be talking about more of the properties of an ellipse and its equation. Stay safe always. Bye!